Have you ever wondered if life could exist in the most extreme environments? The thought is both intriguing and challenging. Picture the blistering heat of hot springs where temperatures soar well beyond what we consider comfortable, or the crushing pressures of deep-sea vents, places so dark and remote that they're often called alien worlds right here on Earth. Imagine the chilling, barren expanses of the polar ice caps, where the sun barely graces the horizon and temperatures can plunge to well below freezing. These are what we call extreme environments, places that push the boundaries of what life can endure. Yet, remarkably, life does endure. It thrives, in fact, in these seemingly inhospitable conditions. Microscopic organisms known as extremophiles have adapted to survive and even flourish in these harsh environments. The existence of life in these extreme conditions on Earth opens up possibilities for life beyond our planet. Scene script. Let us delve into some of Earth's extreme environments and the life forms they harbor. Firstly, the dark pressurized depths of our oceans are home to hydrothermal vents spewing scalding hot water. It's hard to believe anything could survive here, but these vents are bustling ecosystems. Tiny organisms called thermophiles, literally heat lovers, thrive in these sizzling temperatures. They're not just surviving, they're flourishing, revealing a tenacity for life in the harshest of conditions. Now let's journey to the opposite extreme, the frigid expanses of the polar ice caps. It's here, in the coldest places on Earth, that we find psychrophiles, or cold lovers. These microorganisms have made the ice their home, surviving and reproducing at temperatures that would freeze most life forms solid. They have evolved unique adaptations like anti-freeze proteins to keep their cellular machinery running smoothly in the bone-chilling cold. From hot to cold, and now to an environment that's simply glowing. Radioactive environments, places with high levels of ionizing radiation, would be instant death for most life. But some organisms, known as radio-tolerant extremophiles, have evolved to withstand this deadly radiation. They can repair the extensive damage caused by radiation to their DNA, allowing them to survive and reproduce in environments that would be lethal to most other life forms. These are just a few examples of extreme environments on Earth, and the remarkable organisms that call these places home. Each environment presents its own set of extreme conditions, from scorching heat to freezing cold, from crushing pressure to deadly radiation. But in each case, life has found a way to adapt and survive. These organisms, known as extremophiles, have adapted to survive where most life would perish. Their existence challenges our understanding of the limits of life and opens up exciting possibilities for the search for life beyond Earth. After all, if life can thrive in Earth's extreme environments, who's to say it can't exist in the vast expanse of the cosmos? What makes these extremophiles so special, you may ask? Well, their superpowers lie in their unique adaptations that allow them to thrive in conditions that would be lethal to most life forms. These aren't your average everyday organisms. No, these are the superheroes of the microbial world, and their abilities are nothing short of extraordinary. Let's delve into the unique characteristics of extremophiles that allow them to survive in such harsh conditions. Firstly, their DNA. Unlike other organisms, extremophiles have DNA structures that are incredibly stable and resilient. They are capable of withstanding extreme temperatures, high radiation levels, and even the crushing pressures found in the deepest parts of the ocean. This remarkable stability of their genetic material is a key factor in their survival. But that's not all. Extremophiles also produce special protective proteins, known as heat shock proteins. Just like a suit of armor, these proteins shield the extremophile's vital cellular machinery from the damaging effects of their environment. And when the going gets tough, these proteins get going, working overtime to repair any damage and keep the organism functioning. In addition to these, extremophiles have other adaptations that contribute to their survival. Some produce anti-freeze proteins to survive in freezing conditions, while others can enter a state of suspended animation when conditions become too harsh, only to revive when conditions improve. And let's not forget about their metabolic diversity. Extremophiles have the ability to utilize a wide range of energy sources, including light, organic matter, and even inorganic compounds. This flexibility in their energy sources allows them to survive in environments where food is scarce. To sum it up, these organisms are the epitome of resilience and adaptation. They've evolved to survive and thrive in the harshest conditions imaginable, making the most out of what little resources they have. They truly are the superheroes of the microbial world. So why does all this matter? These superpowers make them the perfect candidates for the search for extraterrestrial life. Their ability to survive in extreme conditions on Earth suggests that life might also be possible in similarly extreme environments elsewhere in the universe. So, what do these extremophiles mean for the search for life beyond Earth? Well, the existence of extremophiles broadens our conception of what can be considered a habitable environment. Traditionally, we've thought of life as needing certain conditions to thrive, a Goldilocks zone, if you will, not too hot, not too cold, just right. But extremophiles shatter this notion. They show us that life can adapt to incredibly harsh conditions, from boiling hot hydrothermal vents to the icy depths of Antarctica. This realization has massive implications for astrobiology, the study of life in the universe. If life can prosper in the extreme environments on Earth, who's to say it can't in the far reaches of space? We begin to look at planets and moons not just in our solar system, but in others as well, with a new perspective. Consider Mars, with its freezing temperatures and thin atmosphere, or Jupiter's moon Europa, with its subsurface ocean. Previously thought inhospitable, the existence of extremophiles suggests that these places could potentially harbor life. And it's not just about finding life. Understanding extremophiles also helps us comprehend how life evolves and adapts, shedding light on the mystery of how life began, not just here on Earth, but potentially elsewhere in the cosmos too. The study of extremophiles redefines our understanding of life and its potential to exist beyond Earth. In the vast universe, the possibilities are endless. As we've discussed, life thrives in Earth's extreme environments, showcasing extraordinary adaptations. These extremophiles, with their unique abilities to survive in conditions once considered uninhabitable, expand our understanding of life's potential. They're the key players in astrobiology, guiding our search for extraterrestrial life. Remember, every discovery here on Earth brings us one step closer to answering the age-old question, are we alone? As we continue to explore, perhaps one day we will find that we are not alone in the universe.